This is video number 36 on a series on foundations of arithmetic, algebra, and graphing. I'm Bill Kinney. It's part 5 of a sub-series on exponents, roots, and logarithms with an emphasis on calculator usage. In the first 4 of these videos in this sub-series, we focused just on what does exponent or power notation mean, what are some of the basic properties. In this video, I want to do some applications to give you some motivation for why exponents are useful. Alright, so this says if you get a CD, a certificate of deposit that pays 2% interest once per year, about how long will it take for your money to double? I'm going to use a calculator and do a little experimentation. Zoom in here. It's kind of far away sometimes. Alright, now it turns out that when you're thinking about your money growing this way at a certain percent of interest every year, it actually doesn't matter how much money you start out with as far as figuring out how long it takes to double. But probably it would be easier if we try to imagine a certain amount, just easier conceptually. Let's imagine that you start off with $1,000 in this CD, and it's growing at 2% per year. What does that mean? Well, I had talked a little bit about percentages in the last series of videos, but I probably should talk a little bit more about it now. 2% means 2 per 100, which means for every $100, in this case, your money is going to grow by $2. Well, $1,000 is 10 groups of $100, so your money will grow by 10 times 2, $20 in this first year when you start with $1,000. That's equivalent to multiplying it by 0.02. 2% as a decimal is 0.02. When you say your money grows by 2%, this product here, 1,000 times 0.02, which is what this refers to, that ANS again refers to the previous answer of 1,000. This is going to do 1,000 times 0.02 and get 20. You're going to earn $20 of interest that first year. Probably better show you a little bit on paper. To figure out your final balance after 1 year, then you can think of it like this. You start with $1,000 and you add the interest which is 20, which I'm going to write as 0.02 times 1,000 to get 1,000 plus 20 is $1,020. I want to show you that because of the distributive property, here's an application of the distributive property, I can think of this process that I did there in another way. I can think of there being a 1 times 1,000 there. I can think of this as a two-term thing where I've got 1,000 in each spot. That 1,000 can be factored out. Like this. Do you see what I did? Try going the other way. Try starting with something like this. 1 plus 0.02 in parentheses times 1,000 outside the parentheses. Imagine using the distributive property. What does the distributive property mean? Or say in this case, it says take the 1,000 out here and multiply it times each of those and then add the results. And that's exactly what this is. The benefit of seeing it this way, and let me even rewrite it by the commutative property this way. I'm going to go ahead and add the 1 and the 0.02. The benefit of seeing it this way is it's going to help us see that another way of getting the final balance after 1 year is instead of taking the 1,000 and multiplying by 0.02 to get the interest you earn and then adding the results, instead I can just multiply the balance by 1.02 to begin with. 1 plus 0.02. Just like that. To get the final balance after 1 year of $1,020. And if I keep multiplying by 1.02, the same logic is going to give me my balance after 2 years, and after 3 years, and after 4 years. My balance after 2 years is $1,040.40. Yeah, it grew a little bit more than $20, $20.40. The reason is because your balance was higher after the first year, so 2% of that was a little bit bigger. In fact, it would be $20.40. The next year, it'll grow a little more to that, $1,061.21. It grew by, what would that be, $20.81. It grew a little more. And as far as answering the question now, we just have to keep multiplying by 1.02 until we get to 2,000, until we get to double what we started with. That's going to take a little while, it looks like. Actually, there's a little bit of a shortcut on this calculator. I don't actually have to keep typing times 1.02. If I just hit enter, it's going to keep going. Oh, should I do that? 1.02, well, excuse me, 1,000 times 1.02. Here's what it is after 1 year, after 2 years. Just hitting enter here. After 3, 4, 5, 6, 7, 8, 9, 10. Oh, do I have to keep going? Yeah, let's keep going. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, getting close, 33, 34, 35 is really close. Effectively, it's doubled after about 35 years. Is there a quicker way to do this? Yes, with exponents. We just keep multiplying by 1.02 here. Why not think of the balance after a certain number of years as 1,000 times 1.02 to some power? Well, I know the answer is going to be to the 35th power. I can just do that one calculation right away, if I happen to know the answer is 35 at least, to get effectively $2,000. If you didn't know the answer was 35, you still would have to do some experimentation. Maybe you'd try 25 first and see it's too small, and then maybe you'd try 40 next, and you'd see it's too big, and then through the process of continuing to guess and refine your guess, you'd get down to about 35 years. Turns out there's another way to do it using logarithms, but that's for another video. See if I can do a second related question faster. How much money should you deposit in the CD right now in order for its value to grow to $20,000 after 10 years? If you have to keep multiplying by 1.02 to see how the money's growing, you should divide by 1.02 to see how the money is going to get there, in a sense. You know, if you have $20,000 after 10 years, how much is going to be in there after 19 years? And how much is going to be in there after 18 years? Or, excuse me, after 8 years. So this was 20,000 is after 10 years. That's how much will be in there after 9. This is after 8. Continue dividing by 1.02. This is after 7. 6, 5, 4, 3, 2, 1, 0. That's how much we'll have to start with to get $20,000 after 10 years. There's a way to check it. $16,406.97 times 1.02 to the 10th is $20,000. So the answer here is $16,406.97. Write that down. Instead of continuing to divide by 1.02 in this way, what I can do instead is start with $20,000 and multiply by 1.02 to the negative 10th power. There's the answer. I'd like to stop this video right here, and I would like you to think about, based on the previous 4 videos, and well, in particular where I talk about negative exponents, and I think the last video or 2, why that's another way to get this answer. And in the next video, I'll briefly review why that works.